Now see Newton's second law of motion. See its statement, according to this law, the rate of change of linear momentum, we have done just linear momentum P is equal to m into v. So, the rate of change of linear momentum of a body is directly proportional to the external force applied on the body, and this change takes place in the direction of applied force. So, according to Newton's second law of motion, actually the rate of change of linear momentum is directly proportional to the applied force. Suppose you have taken body this of mass m, it is moving with the velocity v and you are applying force F from this side, velocity is to this side. When you apply force F, its momentum changes or there is, you can say, increase in the velocity. Suppose initial velocity was v and now when force is applied, velocity changes to v plus delta v in time interval delta t. So, change in momentum is equal to a change in velocity, that is m into delta v. So, according to Newton's second law of motion, F is directly proportional to the rate of change of momentum, that is change in momentum divided by time for which the force is applied. So, here we can write F is equal to k I have taken a proportionality constant and that is here change in momentum divided by change in time. See here, we can write here, if you are taking delta t tends to 0, that is very small interval, then you can write F is equal to k dp upon dt, that is a derivative in the differential form. We can write P is equal to k m into here d upon dt m into v. We have taken mass constant, so we can write force F is equal to k m dv upon dt is acceleration, so we can write this. When we choose unit, we can write here for our convenience, here we write k is equal to 1. So, F is equal to m into a. So, according to Newton's second law of motion, force acting on the body is directly proportional to rate of change of linear momentum, and you can solve it, get the value F is equal to m into a. That means force acting on the body depends on mass and its acceleration. For getting the larger acceleration on the same mass, you need to apply larger external force.